Hello there, Mr. Sutton here with the Pre-Cal Honors Chapter 6 Quiz Extra Practice Solutions. There's a puzzle that goes with this one. Let's go ahead and see what we've got in store here. So this is a puzzle I created myself called Answer Checking Anagrams. The idea is I've given a whole bunch of questions based on polar coordinates and vectors, and I also at the very end here, if you look, gave the answers to all those questions. The trouble is, as I wrote in the directions here, I messed up. Some of the answers are one coordinate or one answer exactly too high. It's one too high in the number of the answer. So the idea here is you have to go through, get your answers, check my answers, and then circle the letters of the wrong answers and unscramble those to spell a word with some kind of relevance to this chapter. So, for example, if I do A and I figure out that the answer is incorrect, then I would list A as one of my letters that I have to unscramble at the end. So let's go ahead and give this a try. So we'll start it off with problem A, where we have to list three representations of this polar coordinate here. Might as well start with the original. So this is on ring 5. It's 5 away, so this is going to be 3 comma something. And the angle here is 135, so 3 comma 135. Next up, we can subtract or add 360 to the degrees here in order to get an equivalent point if we keep the radius the same sign. So I'll call this 3 comma 135 minus 360. So this is going to be 3 comma negative 225 degrees. And then we could also change the sign of the radius and either add or subtract 180 to the coordinate. So we've got then negative 3 comma 135 plus 180, which is going to be negative 3 comma 315 degrees. Looking at my answer choice A, or my solutions for A, it looks like I've got all the same angles, 135, negative 225, 315. However, the radius, the R value, is one too far in either direction. So it looks like A is one of the letters I have to unscramble at the end. So let me make a note of that down here, and I'll just keep a running list of the letters that we've found where I had the wrong answer. Moving on to problem B. This time around we need 3 representations of this polar coordinate right in here. So we have an R value of 2, an angle of 240, so 2 comma 240 is one of those. And then I'll just do what I did before. So I'll keep the radius the same for one alternate form and subtract 360. I could also add 360, but I'm going to subtract. So 240 minus 360 gives me negative 120. And then if I change the radius to a negative and add 180 to 240 or subtract it, either way, I'll subtract it this time just to be different. That'll be negative 2 comma 60 degrees. So looking at my answers, we've got 2 comma 240, 2 comma negative 120, and negative 2 comma 60. All of that matches. So B is actually correct, and I move on to the next problem. For the next couple problems, we are given a rectangular coordinate, and we need to rewrite it as a polar coordinate, which means instead of having an x and a y value, we need an r and a theta value. So let me start by getting the r value. That's just going to be the Pythagorean theoremization, or however you want to express it, of my x and my y. So square root of x squared plus y squared. So this is going to be the square root of negative 2 squared plus negative 7 squared. So we have the square root then of 4 plus 49, which is 53. So radical 53, and I'll just leave it in that form because it looks like my answers are in that form, just a simplified radical. Next up, let me get the r value. To get that, I need, so I have the relationship that the tan of my theta equals y over x. So then to get my angle, I need to take the inverse tan of y over x. So that would be the inverse tan of negative 7 over negative 2. And for that, I will need the calculator. So let me do second tan, and then negative 7 divided by negative 2. And let's see here. I'm in, just so you know, I'm in degrees mode, so that's important here. This comes out to 74.1-ish. So we'll call that 74 degrees because the answer choice, it looks like they rounded it off to the nearest whole number. And then one thing I do need to check on this one, it looks like my original point is in quadrant 3. We have a negative x and a negative y. However, this angle that I just got is in quadrant 1. So we have a mismatch between where the angle says my point ought to be and where the actual rectangular coordinates say it ought to be. To account for that, we're going to add 180 to this to get a quadrant 3 version of this angle so that it matches the quadrant 3 over here. So 74 plus 180 comes out to 254. So then my final answer, I'm going to have radical 53 comma 254. And checking answer C, that matches, so it's on to the next. Here we go with problem D. Just like we did before, we're going to get an r value for my polar coordinates by doing square root of x squared plus y squared. So in this case, we have square root of 7 squared plus negative 5 quantity squared. That's the square root of 49 plus 25, so square root of 74, which I don't think has any perfect squares that go into it, so we're going to leave that as is. And I see radical 74 in answer D, so it looks like that's good to go. Next up, just like before, we know the tan of my angle that I'm missing is y over x. So I need inverse tan of negative 5 over 7. Let me run that on the calculator. So plugging all that in on the calculator, again in degrees mode. This is going to give me negative 35.5 and change. So let me call that negative 36 degrees. And taking a look at my quadrants, the original point has a positive x and a negative y, so that puts me in quadrant 4. This negative 36 degrees is also a quadrant 4 angle. These match up, so I can keep my negative 36. I don't have to add 180 to it. So I'm going to write radical 74 comma negative 36 degrees for my answer. And that doesn't quite match my answer. The angle is off a little bit. So I'm going to record D as one of my letters to hang on to, and then it's on to the next problem set. For the next two questions, they're giving me polar points, and they want the rectangular coordinates back. So I'm going to split this up into an x and a y value. So to get the x value, I need to do the radius times the cosine of my angle. So r cosine theta. In this case, that's going to be 5 times the cosine of 32. And again, I want this in degrees because they're giving me degrees. So let me do this on the calculator. So 5 cosine 32 on the calculator comes out to 4.2 if I round to the nearest tenth. And now let me also get the y value. For that, I need r times the sine of theta. So 5 times sine of 32. Back to the calculator. Let me do 5 sine 32, and that's going to give me 2.6. So 4.2 comma 2.6 for that answer. That looks like it almost matches, but they have 3.6 instead of 2.6. So E is another letter I'm going to write down. For problem F, we're doing another one of these, converting it to rectangular. So let me do x equals r cos theta for that one. That's going to be 3 cosine of 143. Let me try that on the calculator. Looks like that's coming out to negative 2.4. For the y value, again, we've got r sine of theta. So 3 sine of 143. Back to the calculator. And that's giving us about 1.8. So checking with answer choice F, with answer F, that looks like it matches completely, so it's on to the next problem. For problem G, we're dealing with some vectors that we're trying to simplify into a single vector. So first off, I'm going to take care of constants outside the vector that I have to distribute, like this negative 1 here. So distributing that through, I multiply it by all the coordinates in there. So this is going to be negative 18, positive 4, and negative 6. And then I'm just going to leave this minus vector as is. Next up, I'm going to subtract pairs of coordinates from each of these vectors. Whatever's in the same position gets subtracted. So I have negative 18 minus 16, which is negative 34. And then 4 minus 10, that's going to be negative 6. And now let me do these z values here. Negative 6 minus negative 5. I'm really doing plus 5 then. So negative 6 plus 5 gives me negative 1. And checking my answer, we have negative 34, negative 6, and then negative 1 does not match 0. So we're going to put down G for my collection of letters here. Now for problem I, we're going to distribute to these vectors and then combine them. So we've got a 6 out here getting multiplied by each of these. 6 times 14 is going to give me, let me think here, 60 plus 24, that's 84. And then 6 times 2 is 12. 6 times 5 is 30. And let's keep, again, that second vector the same. So we have 84 minus negative 2, so plus 2, giving me 86. 12 minus 0 is still 12. 30 minus negative 16, that's plus 16, giving me 46. Looking at answer I, we have 86, 12 instead of 13, so that's different. And then the 46s are the same, but one thing makes it different, so I'm going to keep I and move on. For the next couple problems, they want us to give the component form and then find the magnitude of each of these vectors. So for component form, we have to do basically second point minus first point. You're essentially finding directions to get from point A to point B. So for this one, we've got 2 minus negative 5, so 2 plus 5 then, comma, negative 4 minus 8. So that's going to be 7, comma, negative 12 for the component form. And then for the magnitude, we just have to take the square root of whatever my component form is with each of these things squared and added together. So basically Pythagorean theorem. So I'm going to have the square root of 7 squared plus negative 12 squared. That's the square root of 49 plus 144. 49 plus 144 is coming out to, let me think here, 40 plus that is 184, so 9 plus that, 193. There we go. So square root of 193. I don't think I can simplify that anymore. Let me look at the answer choice just to check. Yep, it looks like everything matches up, so on we go. For problem L, let's start by getting the component form of these 2 points. So we've got negative 3 minus negative 6, so plus 6, comma, negative 1 minus negative 9, so plus 9. So my component form then is going to be 3, comma, 8. And then for the magnitude, I have the square root of 3 squared plus 8 squared. So square root of 9 plus 64, square root of 73. Let me check answer L. 3 comma 8, yep. And then radical 73 matches, so L is also good. For M, they're giving us 2 vectors and doing some manipulations with them. I'm going to start this problem by replacing these vector variables with the actual component forms of those vectors. So negative u, I'm going to write negative 5 comma negative 7. And then for 3w, I'm going to do 3 times 9 comma 1. Let me distribute now, and then I can combine the vectors together. So I've got distributing the negative here. This is going to be positive 5 comma positive 7. Distributing the 3 over here, I can call this 27 comma 3. Now let me just add the x's and the y's. So 5 plus 27 is going to give me 32, comma, 7 plus 3 gives me 10. 32 comma 10 almost matches M, except they have 11 instead of 10, so I'm keeping the M. For this next one, let's start by replacing the u and the w with the vectors that they represent. So we've got 2 and then the 8 comma negative 5, minus 6 and then 7 comma 2. Let's distribute those constants outside now. So we have 2 times 8 is 16, and then this becomes a negative 10. Over here, I'm just going to distribute the 6, and I'll leave the negative in place. So we've got 42, comma 12. Now let me subtract each pair of coordinates. 16 minus 42, that's going to be negative 26. Negative 10 minus 12 is going to be negative 22. Let's see if that matches up. So that's n right here. We have negative 26. They have negative 25. The 22s match, but one of these is off, so let's keep n. For this next set of problems, we're being given 2 points, and we have to find another point that is a fraction of the distance from A to B. So our strategy on both of these is going to be to find the component form of a vector going from A to B, and then just add whatever fraction this is of that component form to the original point. So let's get our component form first here. That's going to be 29 minus 8, comma 18 minus 4. So to get from point A to B, we have to do 21, comma 14. 21 steps to the right, 14 steps up. Next, I'm going to do point A plus 4/7 of this component form. So that's going to be 8, comma 4 plus 4/7 of 21, comma 14. So 8, comma 4 plus, let's see, 21 divided by 7 is 3, times 4 is 12. And then 14 divided by 7 is 2, times 4 is 8. 8 plus this 12 here is going to give me 20, comma 4 plus 8 is going to give me 12. So that's my new point that's 4/7 of the way between these points. And that, it looks like, is going to match what I have in O, so I get to move on to the next one. For this one, we're trying to find a point that is 2/3 of the way from A to B here. So again, let's find the component form first to get the total directions to get from one to the other. So we have 1 minus negative 5, or plus 5, and then negative 23 plus 8, because minus negative 8, giving us a component form of 6, comma negative 15. So we're going to be doing A plus 2/3 of AB to get our point P here. So negative 5, comma negative 8, plus 2/3 of this 6, comma negative 15 that I just found. So there's our original point. We'll just copy that in there. And now 2/3 of each of these, I'm going to divide by 3 and multiply by 2. So 2/3 of 6 is going to be 4. And then negative 15 divided by 3 is negative 5, times 2 is negative 10. Adding these up, we have negative 5 plus 4, that's going to be negative 1. And negative 8 plus negative 10 is negative 18. Taking a look at that answer, we've got negative 1, comma negative 18, just like I have here. So that matches up. We move on. I have not collected any letters for a little while now. For the next couple questions, we're doing some dot multiplying. The idea here is I have to multiply the x's together, I have to multiply the y's together, and then I have to add those two products. So I'm going to have negative 2 times 6 plus negative 9 times negative 4. So negative 12, and this is plus 36 here. That all adds up to 24. And 24, checking answer R, is what I get. So let's move on to the next. Dot product on this one, we've got negative 5 times 4 plus 7 times 5. So this is negative 20 plus 35, which comes out to negative 15, or positive 15 rather, because we have a negative that's smaller than a positive. And then S is 15, so let's keep going. For problem T, I need the midpoint of these 2 points. The basic idea here is I'm just going to average the x's, average the y's, and average the z's together. So using this formula, one coordinate from one point plus the same coordinate from the other divided by 2 for each of those. So I'm going to have 11 plus 13 over 2, 8 plus 12 over 2, comma negative 5 plus 7 over 2. This is going to be 24 over 2, which is 12. This is 20 over 2, which is 10. And now this is 2 over 2, which is 1. So 12, comma 10, comma 1. A lot of things to keep track of. Checking my answer. It looks like everything checks out except for this 11 that they had instead of the 10. So I just found a letter I can collect here, and that's the T. Finding midpoint on this one, again using my formula where I'm essentially averaging all the same types of coordinates together. We've got 25 plus 15 over 2, negative 12 plus negative 4 over 2, and 13 plus negative 21 over 2. So 25 and 15 is going to be 40 over 2, so 20. This is going to be negative 16 over 2, so negative 8. And 13 minus 21 is negative 8. Over 2 gives me negative 4. U has most of that except this negative 7 is different from the negative 8 that I got here. So I'm also getting a U, so that's 2 letters in a row. Next up, I'm finding the distance between 2 points in 3-dimensional space. So I'm going to be using Pythagorean theorem on this one, only with 3 coordinates instead of 2. So I'm going to have the square root of x minus x squared, y2 minus y1 squared, and z2 minus z1 squared. So we're going to do square root of, let me think here, 0 minus negative 8, so 0 plus 8 squared, plus 8 minus negative 3, so 8 plus 3 squared, plus negative 4 plus 6 quantities squared. This is going to be 64 plus 11 squared is 121, plus 2 squared is going to be 4. 64 and 21, that's going to be 185 plus another 4 gives me 189. So I've got square root of 189. And checking V, it looks like they have something different. So it looks like I can simplify this radical. If I split that up into 9 times, let me think, I think that would be 9 times 21. I can square root the 9 to get 3 radical 21. So yes, that does check out. V is not a letter I can take with me here. Let me find the distance now between these two 3-dimensional points. So again, we've got super Pythagorean theorem kind of thing going on here. Super distance formula. I've got 1 minus negative 7, so plus 7 squared as the first thing inside my square root, plus 9 plus 7 squared, plus negative 3 plus 2 quantities squared. So that's going to be 8 squared, so 64. This is 16 squared, so 256. And then this is just negative 1 squared, so plus 1. So let me think. 64, 256, that adds up to 320, plus another 1 is 321. And I've got the square root of 321 down here, so I don't think I can simplify that anymore anyway. No perfect squares that actually go into that. So moving on then, we're going to say W is not something we're taking. For my last 2 questions, I've got just some 3-dimensional vector sort of algebra here. So let me start on this one by distributing this 2. That gives me negative 18 minus 20 and then positive 8. And I'll keep my dot multiplying in there. So now I'm going to just, again, multiply the same coordinates together and add everything. So we have negative 18 times 8 plus negative 20 times 7 plus 8 times 3. Negative 18 times 8, what is that? Well, let's see, this is like 80 plus 64, so that's negative 144. This will be negative 140, and this is 24. So let me think. Negative 284 plus 24 is going to be negative 260, which matches what I have for answer Y. So on to the next. So here's our last problem, some more vector algebra with some dot product thrown in, 3 dimensions. Let me start by distributing this 10, so I'll keep this first vector the same, and then we've got 40, comma 10, comma 30. And now let me do my dot multiplying. So negative 3 times 40 plus negative 8 times 10 plus negative 1 times 30. I feel like this will be a little easier with the arithmetic than the last one was. So this is negative 120 minus 80 minus 30. So let me see, negative 200 minus another 30, negative 230, which matches what we have here. So I had to check, but none of these last few letters, after U, nothing actually got kept. All the answers were correct. But I had to know if there were any more letters that I had to factor in. So now I can go on to actually solving the puzzle. So here are the letters I collected that had wrong answers. I have to unscramble these to get a word that has some kind of relevance to polar coordinates and or vectors. So let me think here. This is a long word. We've got a G and a U and an M and all these crazy things. I'm thinking some long words that have to do with the vectors. Let me see here. M, A, G. If I can spell mag. So magnitude, let's see if I have the letters for that. I have an N, got an I, T, U, D, E. Yes, I can spell magnitude with those letters. Awesome. Well, until next time then, Mr. Sutton signing off.